So hello everyone, we will be learning our very last thing for the year, and this is geometric probability. And so the geometric probability of an event occurring is found by determining a ratio of geometric measures such as length or area. It's used when an experiment has an infinite number of outcomes. So let's take a look at these examples. So it says find the geometric probability using length and then using angle measures. So it says a point is chosen on AD, so on the entire segment. Find the probability that the point is on BD. So BD. And the way you do these is you count all the points on BD and you divide it by all the points on AD. So for example here, BD, we have B and we have D. That's 4 plus 6. So that's going to be 10. Over all of them in total, that's 4 plus 2 is 6, plus 6 is 12. So it's going to be 10 out of 12. We will be reducing that to 5 out of 6. For all of these, you do need to reduce them as much as you can. For when we are using angle measures, it says use a spinner to find the probability of the pointer landing on the 160-degree space. So you put all the points in this region, so that's 160, divided by all the degrees in a circle, that's 360. And so that actually reduces to 4/9. So let's do a couple more of these. It says a point is chosen randomly on EH. Here we see from E all the way to H, that segment. Find the probability of each event. We are doing the point of segment FH. So first thing I'm going to do is count out of all of these in total. So that is 5 plus 6, 7, 8. So these are going to be 8 in total for all of them, right? So 8 in total. And then it says how many for F and H. So I want this entire segment right here. I add both of these up, and that's going to be 3 out of 8. That's it. That's my answer. Then I'm going to say, which one should I do? Let's do number 3. So number 3 says segment of EF or GH. So those are two separate ones, and remember, every time we have two separate ones, we just add those two up. So I know that's first point is going to be out of 8. So EF from E to F, that is just 5, plus G and H, that is just 2. We keep the bottom number the same, we just add the top, and so our answer here is just 7 out of 8. So I want you guys to do number 2 and number 4 and go ahead and get that checked off with the sub. Reminder or a big hint for number 2, the probability of something not happening is 1 minus the probability of it actually happening. Okay, so count the points on EF and subtract them from 1. So get those two checked off, and then we'll come back and do number 5. So hopefully you got those two correct. Now let's try one of the angle measure ones. So the angle measures, reminder, it is out of the degrees of a circle. I know these don't add up to 360, but they all will be out of 360 anyways, just because that is the measure of the circle. So then it says the pointer landing on 135. So we would do 135 out of 360. And so once we do that, we can just reduce it to its lowest form. And so for number 6, now we want to do 75 out of the total number in the circle. That's going to be 360. And once you reduce that, I think that should be around 5 out of 24. I think this was 3/8. I might be wrong. So you guys go ahead and check it on your own. But I think those are the two lowest or the simplest forms. So you guys try number 7 and number 8. Hint for number 7, you add these up. 90 and 75 over 360. So get those checked off, and then we can go ahead and do the back page. Those last two should have been pretty easy for you. And let's go ahead and try some with area. So you can actually do these with area as well. And so the way you do these is you take the area of both figures. So you're going to take the area of the rectangle, or in this case the area of a rectangle, and the area of a triangle. But let's do another one of these examples. Let's do this one. So here it's asking us to find the probability that a point is chosen randomly inside the rectangle is each shape round to the nearest 100. So here I'm going to need two things. I'm going to need the area of my rectangle. Reminder, that is just length times width. But I'm also going to need the area of my square. And so that is just going to be s squared. So for my rectangle, that is going to be 7 times 4. So the area of my rectangle is 28. For my square, I have a side of 2. I'm going to square that. So this will be 4. So remember, we want the square. So the square, whatever they ask you here, is going to go on top. So we are going to say a square divided by a rectangle. So the area of the square divided by the area of a rectangle. Oops. So this is going to be 4 divided by 28. And you can leave that in decimal form, so just divide 4 by 28. And when we do that, that is going to end up equal to around 14.14. Okay, so whichever they ask you for each question, that's the one that's going to go on top. So for example, in the circle, I'm going to need two things. I need area of my rectangle as well as the area of my circle. So we said that was length times width, so we are going to say that's 16 times 22, which ends up being, I think, 352. For my circle, that is pi r squared. So that's going to be pi, my radius here is 8. I'm going to square that. And so we get approximately, I think it's going to be around 201. I don't know why this is coming out so squiggly, you guys. Sorry about that. So, reminder, we do what we want on top. So it's going to be area of my circle divided by area of my rectangle. So that's going to be 201 divided by 352. And when we end up doing that, that should be around, it's not an area, it should be around 0.57. Okay, so you're going to do the same thing here. You're going to find a triangle, area of my triangle divided by my area of my rectangle. You're going to do number 10, go get it checked off, make sure you get that right, and then you can go ahead and get started on your homework. So come to me Monday, B lunch, if you didn't understand this, and we can get that solved right away for you.